Up until lunchtime, we're going to be talking about tracking. We're going to be using software called P-FTrack, which some of you may have played around with. We're going to be talking about tracking a quite ambitious shot, which caused us some troubles. It was one of the first shots we worked on. And I'll show you the shot we're going to be working with. And first, let's just find that shot in TRA30. So this was one of the more ambitious shots that we've created animation-wise, and we're kind of going to go through this. We've been talking about this shot a lot today, specifically in the afternoon with a lot of the animation techniques that we use. But let's see if this plays back with a decent speed. So this shot was a key moment in the film where everything is transforming. The town is kind of changing over a kind of 50-year period in real time, which is quite an abstract concept, but it really adds to our kind of approach that the kind of architecture and the design of the environments were kind of part, a character in itself, basically. So we've got a kind of like a little kind of making of thing here, which kind of explains a little bit more visually before we get too technical on this particular shot. So you can see here, we've got the kind of start of the shot, and then it will kind of rewind and show you how the shot was kind of started from the kind of initial footage to elements like this, which were kind of designed and animated to kind of build up out of nowhere. We're kind of embedding it within the scene. We're rotating out the characters, and we're rendering lots of different elements separately. This was never rendered as one shot at all. It was rendered as like 10 different passes that were kind of composited in. And these are some of the elements we're going to be looking at later on within the animation. And some particle effects that were kind of created. So again, appear out of nowhere. And it's quite a popular kind of thing to do within architectural visualization as well, this kind of transformation of elements and this building of this new scene or this new kind of area that's kind of being built up by the architect or developer. And a lot of these techniques can be kind of applied to lots of different purposes, but for us it was this kind of magical transformation of our Zanzibar stone town. And then this is the final shot. So, first step in this process was obviously tracking. And there's a few things that we can set up. We're going to be talking about how we did all of these different things. So this is our kind of, this is our P-FTrack window. So let's talk first about the kind of interface of this thing, because it can be quite alien to a lot of other softwares that we use, and it works very differently as well. Let's just check how we can get this not full screen. Okay, so for those who want to work not in full screen mode, which is the default for P-FTrack, then you just have to press this full screen GUI. I've always worked with it in full screen mode. I've never really needed to not do that. But if you've got a projector that doesn't display your viewport, then that's the button to press. So let's just work with a fresh scene, a fresh kind of view. Let's kind of talk about the UI for this. So, when you first open up P-FTrack, it's going to give you kind of a window like this. You're going to have three main kind of areas at the top. The kind of node tree area on the left here. We have our kind of asset selection, where we will store our kind of assets in the middle. And then we have our kind of browser folder on the right here. Before you do anything, down the bottom here is where we kind of create and edit everything we do in P-FTrack. And the first thing we want to do is create a new project. So we go to our project symbol here, and then if we just kind of unlink our current session, so this will be the brand new session that you'll kind of see, and you want to create a new scene. So this is when as soon as you press create, it will ask you to confirm. But before you do that, you want to just select the path from where you actually want to save this session to. You can select the frame rate. It's good practice to do it at the beginning, but you can change this at any moment. You can do camera presets and things like that, and again, that doesn't really need to be set at the beginning. So we'll call this CG School. And we'll press create and confirm. Sorry, we've just undid that. So now we've kind of got a new window, and we can begin with our scene. So first thing you want to do is locate your footage, which you will want to do on the right-hand side here. So we'll go to our folder, and we'll bring in, say, our footage here. We'll bring in a undistorted sequence. Street scene footage, sorry, there we go. And we'll just click and drag that into our folder here. And we could have clicked and dragged that directly into our tree, and that would have automatically put it within our kind of project folder here. We can see where all our assets are if we click on this top symbol up here, switch to From Media Admin, and this will give us a list of our assets, and we can relink and delete them here, basically. Then we go back to our node tree symbol, which is the top button here. We can just unclick that on there. So basically, we don't really want to see all of this all the time. So we kind of want to essentially turn those off and go into camera mode, which essentially just displays what you've got selected in your tree. And that's where you'll work for most of the time. But if you wanted to bring anything else in, then we can go back into our selection here. And then camera mode defaults back. So basically, what we want to do is begin to kind of track this scene, but we want to do a few things first. And it really depends on your setup of your camera, your setup of what kind of cameras you're using. And in this case, we were using the Alexa on an 18mm lens. And it's really important to record everything. And to kind of illustrate this, we created a kind of what we do before every project of a certain size is create a VFX outline. And it's really good practice to do this. And we could use the previews we created and to kind of like illustrate which shots we're talking about. This is just notes and referencing, and then this is kind of outlining the different sequences that we had to do. But then specifically, if we go down to any of the shots, if we look at this shot in particular in the previs, which was this one here. So this is the previs of this shot, but then what we want to do, we have this on location, and we talk about the camera type, you know, the Alexa, what lens we've got, what focal length we're using, what aperture, whether it's a fixed camera on a tripod, whether it's a free camera, whether it's got any green screen needed, whether we need to put tracking markers in the location, and whether we need a mirror ball capture or HDRI taken, what kind of roto might be needed, and if we need a checkerboard capture. So some things we can kind of try and guess before we go, and then obviously the camera type and all the lens equipment needs to be decided on site. So we'll do this for every single shot, and this was a really extensive document that was made, which kind of goes through every single shot within the sequence. And we had this in a big folder when we were on site, and we were documenting everything down. So we had a kind of Bible for our visual effects. So always record and create these documents when doing anything complicated or any kind of on-set shooting. You should have a document like this. And again, that's another reason why the previs was always so useful. So we've got our footage. We'll start tracking it, right? That's what we do in tracking software? No. What we want to do is, depending on your camera equipment first, is correct the rolling shutter of your footage. Now, You don't need to do that on the Alexa, but chances are you won't be using the Alexa. Chances are you'll be using a 5D or anything like that. If you're using the Red Epic or the Arri Alexa, then you won't be needing to do this step. So we'll delete our auto track. Everything works with double kind of deleting or double clicking, because it makes sure that you really want to do it. So if I press delete on here, it will ask you, do you really want to? Yes. Or if you click away, then you stop that. So just make sure you can't delete anything accidentally just by pressing it once. So everything kind of works in the same way. You kind of have to double click most things. So say we're using a 5D Mark II, for example, and we need to fix the rolling shutter. What rolling shutter is that most kind of digital cameras that are kind of used for video recording, like the Mark III or this generation of cameras that can do footage that people use, including ourselves for most of our other projects. It has a kind of, the way that it captures the images from a top-down order, so that it basically scans the image from the top down, and it's the film speed which creates a kind of distortion in the image, which can be a problem for tracking. Because the film speed of these kind of cheaper digital cameras is not fast enough, like they are on the much more expensive cameras like the Arri Alexa. So you get a kind of slight tilting or a warping to the image. So let's just bring in some footage, and we won't have any effect on our footage because it is already it doesn't have that problem. But just to show you where that actual feature is within After Effects, you can do this directly into P-FTrack. But it's a much more robust system that they have in After Effects, basically. So you can see here what the raw footage looks like, actually, which is a good example. You know, it's very flat. It's recorded in Alexa log, and this allows for an extreme amount of data within the file to bring back all of that detail in post-production. But again, all we want to do really is once we have our kind of footage in place, create a new adjustment layer, and we want to go to the rolling shutter repair. And you can actually see it has made a slight difference to this footage, actually. But it's not something that you really have to do on the Arri Alexa log, but it has made a slight difference. And it's as simple as that. You don't need to change much else. You might want to change the method to pixel motion, which is a slightly more accurate, detailed result. And again, it is making subtle changes to the image. And again, because your digital camera is scanning from top down, when you're moving the camera, you can get lines might be distorted and warped so that it's not fast enough. And you'll notice this difference considerably. You'll notice the difference a small amount here. If I zoom in, you can kind of see that difference. But on the 5D footage in particular, or any other kind of camera of that spec, you'll notice that difference quite a lot. Scan direction top to bottom. And in the rare case that you're kind of like doing a portrait or you're filming in a slightly different way, you can also change this to be left to right or bottom to top in the rare instance that you'll be filming portrait or filming your camera upside down. But it gives you that feature to be able to change things there. You can change the amount here, and again, 50% normally does it, but you can sometimes go up to 65 to kind of like fix your shutter, and it's just checking when things are straight when you know they should be. Some cases it's hard to see, but normally about 50 to 65 does the job. And then what you want to do from this footage is you want to export it out as an EXR sequence so that you're not losing any data from your image, because you want to keep the footage in 32-bit. If it is 32-bit, as long as possible. If you're filming on the 5D, then most likely you'll be filming JPEG resolution, JPEG compression anyway. So it won't really matter. You can save, but it's best to kind of keep. You don't want to add to that degradation, so you don't want to JPEG it again. Keep it as a kind of EXR sequence. We don't really use TIFFs in animation. TIFFs are extremely heavy file format, and you don't want to use them mainly. EXRs are much more optimized and they actually contain equal to or much more data in fact. So yeah, watch out for that. So all we need to do now is export this and we can use that as our new footage that we'll bring into P-FTrack. And you always save it as corrected or something that makes sense for what you've done. So shutter repair, save it as shutter repair. And then you'll bring that footage into P-FTrack as a starting point. But we don't need to do that because we've got the Arri Alexa footage here. Likewise, if you're filming a high-end project on a RED, you wouldn't really need to do that because the difference is minimal and it shouldn't really affect our track. So this is kind of the interface. So if we double-click on our footage, we can see that we can kind of set frame rates, the in and out point. We can offset the footage, and then we can kind of select from different kind of presets here, and you can save your own. And if we select custom, then we can set everything here, and then you can kind of save your preset, which will save within the kind of P-FTrack menus here, basically. So what we're going to do is I'm actually going to load my, the kind of the scene that I've already created, and we're going to try and rebuild this this scene from scratch. And the way that you load previous projects in P-FTrack is quite interesting. P-FTrack doesn't really save in the normal way. It kind of has micro saves every few seconds. So there's no like file save option within P-FTrack. It's always saving. So wherever you've set your path to at the beginning, it will always continuously save every microsecond. So if you have a crash, or if you want to close, so if I press the close button is up here. If I press yes, that's gonna close the software. And when I reopen it, what it's going to do, if I close it, minimize this, and reopen P-FTrack, it's going to automatically load my last scene I had open. So how do you open previously saved files? If it's always going to open my last scene, you need to somehow be able to load previously saved files. So again, in project, if we just let this load for a second. P-FTrack clearly didn't have its coffee this morning. Okay, so we're in, and we can see that our file CG School has is open. And we can see where it is where we left off. It's somehow missing our footage. So let's have a quick look at what's happening there. Nope, it's just loading it. It's just taking a little bit of time to reload this this footage. This is a large file. This is the kind of 4 gig uncompressed file. So it might take a little bit of time to load the media in there. But again, if anything goes missing, you can kind of make sure that it's attached there. So that should be fine. But what we want to do is we want to unlink this project, and we want to relink from a different file. So let's try and find our footage, our previously made file, and look at how we can go about rebuilding that. So let's go to animation, tracking, and then you can see it here, PFMP, whatever that stands for, and then we can open that. So we need to click on it and press the switch. Now we'll be entering our previous file. So I'm going to run you through the kind of basics of what we're doing here, and then in a new file we'll try and replicate some of the processes that we did. So first of all, double click again, and then within your window here you'll see your footage. So this is the normal footage. Nothing's been adjusted here just yet. And just to kind of, everything is controlled with the mouse. The left click is your marquee tool, your right click is your pan, and your middle mouse button is your zoom. And that kind of works with all windows. The same functions within all windows, and you can kind of zoom in and out by dragging the middle mouse button left and right. Let's move this down. And then you have, over here, you have different window options. This is one window, two, and so on. But you're not really going to be able to see anything in here because we haven't created our 3D scene. We haven't solved our track. So we just want to be working in one window at the beginning of our set. So obviously within the middle here, this should be familiar to most people who are using any kind of animation software or After Effects or Max. You have your in and out point of your footage. So we have here 315 to 1300. that's our frame range of our footage that we're looking at here. So what we want to do first of all is we want to set our camera settings. So I know that my camera setting for this camera has a film of the Arri Alexa is 23.76 millimeters. Now on the 5D it's 36 and so on and so forth. So you want to just make sure that you've got your camera setting is what your camera actually is on your footage. So you display that here. So you change the film back to whatever the camera is you're using. The frame rate and then the in and out point can all be changed here, and again the offset. And you can save this preset and call it Arri Alexa. There, that's fine. And then you can reload it. So you don't have to keep doing these settings every time. If you use the 5D for all your shooting, then you can just have a 5D preset and then always use that when you do your tracking. So let's have a look at some of these nodes. So the first thing you need to do when you're working with any of your footage is underdistort your footage, right? Now, there's a few ways you can do this. The thing is, when you're working with a shot like this, is that I'm not sure I can really trust any of these surfaces in a place like Zanzibar. Are any of these lines really straight? That the buildings were pretty wonky, most of them. It's really hard to judge a straight line from a building like that. So I can't really trust any of these surfaces or walls to be straight. So what do you do in this instance? It looks really easy, you just take some lines, but you want it to be accurate. What's really good practice, which you can do on any camera, is shoot a grid test with a label of what lens you're using when you're shooting it. So this, we're shooting on an 18mm lens, fixed. We're not changing that lens, we're not animating that lens in our camera. So we've kind of shot a grid test. Doesn't matter that it's not slightly straight on. Ideally, you'd be kind of as straight as you could be. But what you want to be doing is shooting this on the Arri Alexa. It's not a camera. It's not a photography camera. So you have to actually film it. So this is actually a still from a piece of footage taken on the Alexa. But and you want to do the same thing on your cameras on your 5D, because the picture, if you take a picture, it might be slightly different to what the film is. So you want to make sure that what you're undistorting is in the same format and the same spec as your footage. So do a couple of seconds of filming of a grid test and just print these out and then laminate them or something until you have a few of these lying around the studio. And then what you can do then, if we click on our undistortion, we can see that we've distorted it here. So in a new file, what we'll do is we'll select both of our footages here. We'll press our copy button, and then in a new file here, a new window, we'll paste them in. And what P-FTrack can do is that it's got these kind of, let's just see that we've got the right thing open here. Let's just double check that we've got the right scene. Hang on 1 second. We might have opened up the slightly wrong scene, so we'll just go back to project before I continue and unlink. So if you need to kind of change your scene, you need to unlink and relink your scene. Let's just double check where I've saved this to. It's opened up the slightly older footage that we have. Okay, so what happened there was that when we had that system crash earlier, when we were trying to load a file into P-FTrack, and we had to reset our machine, it then corrupted the file and it has resorted back to a much earlier version. So watch out for that. It's actually the first time I've ever lost work in P-FTrack because of the autosave feature. It normally is very robust. I think in this case, because we were, you have to work within one machine on P-FTrack. You can't really copy the file and relink the footage if you want the user tracks to kind of be working. So our previous track that we did in the UK wasn't working when we came here, so we had to retrack it over the last few days, which we did, but then we've now lost that data. So what we're going to do, we're going to proceed with this anyway and go through all the concepts that we need to do. Tracking is a very repetitive process. We might have to avoid doing some of the finer details of that repetitive process. So we can't guarantee that we'll have a solid track at the end of this. But what we will do is that if we don't get to a resolution with this by the end of this morning, then we'll pre-record this separately and include it within the download that everyone will be getting anyway. So, but we'll definitely learn a lot from what we have to do here in all of the processes that we need to do for tracking a shot. So, first of all, what we're going to do is we're going to kind of limit our frame range. We're not going to track the whole shot for this case. We're going to kind of like start it off, let's say 340, and we're going to finish around, say 650. And we're going to kind of work with a shorter clip for this illustration. So you can see here we've got a massive problem with this scene, which is like hugely obvious. We've got our two main characters kind of obstructing a lot of what we want to track, which is a huge problem because we're going to get loads of tracking errors with these people in the way. So I wanted to kind of show a more complicated track so that it's not something that's just a point and click approach, which tracking often is, but often isn't. Sometimes if you've got a simple approach, simple auto tracking and camera solving will work. But when you've got a complex shot like this with a huge problem in the foreground, it can take a little bit more effort. But first of all, what we want to do is we want to kind of undistort our footage. So what we do, all the commands are available in Create, but they're also available by right-clicking on the main footage. That's where I access all my nodes from. So the first thing we want to do is undistort our footage. So we get our distortion node here and loads of different kind of parameters. So what we want to do is draw a new line. And then what we can do, we can already see the distortion in this image here. You can see it. So what you want to do is you want to click and drag a line. And then you want to kind of like add in points to that line to say where that distortion is. And if you press Shift, you can actually pinpoint accurately put that line where you want it to be, exactly in the middle of these points here. Likewise with our first point, we'll put him exactly there. We'll add another one on these grid lines. So if we zoom into this, we can see that this is our distortion line, and on the side is a representation of what the still line is, of what an absolutely straight line is. And it's going to kind of like distort the image based on that difference between these two lines. Now, you don't have to put loads of lines in, but it's good to put one or two. So we'll do another line here, click and drag across the bottom. And then using Shift while clicking on the point, we'll just make sure that's pinpoint accurate on our grid. Don't need to put points on every single part of the grid line, but we'll put a few in just to make sure we've got a good accurate distortion. And then you could just press Solve down here. But what we want to do first is also measure the high order and then click Measure. What this is going to do is it's going to distort the image, but it's also going to make the image bigger based on that distortion. So you're not actually losing pixels when you're distorting the image. You're kind of just making the whole image bigger. And then we'll kind of illustrate this by solving our camera here. So you can see exactly what that's doing there. It's kind of flaring out the image, but it's also made our image now from 1920 full HD to 1967, basically. So we did the same thing in our track here. We've got our distortion. The one thing we did do actually, which we've got to do, is make sure our camera's focal length is on 18. So everywhere you can put this in, you need to make sure that you're making sure the camera is at 18 millimeters or whatever your camera's set to, so that the distortion can be as accurate as possible. So we'll go ahead and solve that again, just to make sure that the camera's on the same page. So then all we want to do with this is we want to copy it and paste it, and then we just connect it to our footage here. So we double click the footage there, double click the distortion there, and you can see what we've created. So what we want to do now is we want to, if we were kind of working with different footage, we could have, before we did this, we could have used the the shutter fix, but again, we went through how to kind of do that in After Effects in a slightly more reliable way. The shutter fix in P-FTrack is good, but it's not quite as good as the After Effects one. If you wanted to keep it all within one tree, you could have done this after your footage, but we don't really need that here, so we'll delete it. So again, what we want to do now, we want to add an auto track to our scene, and what that's going to do is place points, track the kind of pixel motion of the points around your scene. Now, our kind of footage is quite flat here, and there's lots of ways we can kind of like help our track work a little bit better. If you go to the enhance feature in the nodes, which appears on some of the nodes, not all of them, only the ones that actually require you to have that feature, we can click color, and then we can kind of affect our gamma, our brightness. We can really kind of play around the settings here. We can add a curve instead, and we can curve up our footage to give it more contrast. But what this is going to do, it's going to kind of take more RAM, because you'll kind of have to process more things, and it can sometimes slow down your footage. It's going okay here, but we might need to cache our system to load the file into memory to make it work faster. But we'll just abort that. You can see that it's loaded now this into RAM. You can do the same thing by just playing through your footage and it will load it into RAM, just for the sake of speed, by working with it and seeing how the tracks are working. But what I like to do is neither of those. I like to use the graphics card and selecting Cineon, and then changing the settings here to make it more contrasted. Because we're working in 32-bit, you can really see how much data we've got in this footage. Let's just fly to a bit over here. You can try all sorts of different ones, see what features they have. But essentially what this is going to do, it's going to use your graphics card instead of computing it on top of the image, so that you can kind of work with the file faster. Let's just make a quick adjustment here. Let's just have a look at some of these other features. So let's try this matrix one instead, actually. Let's give it more contrast. Let's turn the brightness down a little bit. So yeah. And once we close that, we can activate it by pressing this little button here. Ah, we didn't press OK. We just closed it. Sorry. Let's increase the contrast. Okay. So then we can have it active there. And then what we can do when we come into our enhance mode is that we can turn on color, but then use the display LUT instead of anything else. And then that will give us a much kind of faster result in our viewport, and without having to load that color correction into RAM. So what we want to do with this auto track feature, if we go back to parameters, we want to edit the target number. We want to kind of increase this really. We want to kind of give this a few more tracks in this particular case. Feature scale is small, which is good. There's all sorts of things we can change to do with the kind of camera. The main thing we want to change is the search mode from better speed. Better accuracy sounds tempting, but actually optical flow is the better one to use in this case. And yeah, there's all sorts of other things we can kind of change, the kind of length that the trackers look for, the kind of pixel size. But most of this can be stayed at default. The only other thing we kind of sometimes change is the window size, which is the default kind of size of the square element of the track, which is actually pinpointing on top, which is more obvious when you look at some of the auto track features. Some of the manually tracked features, and we can kind of manually adjust those for each one. But this is essentially the size of that box, which contains around the pixel that it's looking for. And then the length, which is the kind of like, it's almost like a fall-off line behind the track pixel, which helps in smoothing the motion. We can change a lot of these different features, but most of the time we can just leave things on default and up the target number a little bit. And the candidate number, which is just the search range. So if we take this clip and we do an auto track now, you can see that it's picking out all of the points that it kind of feels like it can see and read as separate kind of like isolated elements within the scene. And we'll go through which points are good points, which points are bad points. It's really obvious which points are bad points, the ones that are moving on our guys here. And there's lots of ways that we can kind of deal with this. If we just pause this for 1 second, we stop the track there, so no more tracks are there. One thing we can actually do is mask our characters. So what we can do, we can go down here and press mask. We can go click on a Bezier roto, and we can kind of manually draw around our characters here. And then what we can actually do, which is a really great feature, is we can actually start to track this roto in place. We can do it manually by 1 frame, or we can kind of let it kind of process and try and track where this is covering over a certain amount of time. And it will track the general shape. So you might want to do this first, and then after it's kind of tracked and processed, you can then manually manipulate these Bezier points as well, so you get a really accurate kind of like covering of your character. So we can add lots of different masks. So if we stop that there, we can see that we've now got quite a good track on our character here. But then in addition to that, we can zoom in and actually start manipulating these points to be a little bit more accurate. And it's kind of like it's exactly like rotoing. You don't have to be too accurate. You just want to make sure that you're not covering too much of the image, which is kind of the problem with this workflow. Unless you're pinpoint accurate, certain points that it covers, it might actually be good points to kind of track with. But this process can work quite successfully. Again, it's just going in and making sure that your bounds of these points are as tight as possible. That's actually, those points are actually animating along with our mesh there. And then when we came to auto track this, it would ignore all of those points. So we can kind of, if we wanted to kind of start this again, select all of our points and remove them all. Just remove our points 1 second. So you can see now if we do another auto track now, oh, hang on 1 second. Where did we put that? It starts from there, so it starts from 340. Let's just do that again. It's for some reason lost our track, unless our track starts from there, yeah. So our auto track is actually starting before our frame range, which we should adjust. But you can see now it's actually not making any points within this mask at all. Yeah. Which is exactly what we want. We sometimes use this method, but what we actually find is sometimes a faster way of working, especially if you've got more complex objects. If you go to our mask, we just deactivate that, so it's not actually affecting the scene. And we go back to our parameters and delete these guys. If we just do another auto track and let that go for a second, and we'll let this kind of cover our entire frame range, is that we like to just go in and manually delete the points that we think are causing a problem. Tracking can be one of those things where it's as good as the time that you spend on it. It's just like anything else, just like any kind of modeling or texturing. You have to really spend some time really adjusting your track, especially if you've got a more complex situation. Tracking is not a point-and-click solution like some people think it is. It's not like some software won't track it. Oh, I'll try a different software. It's really spending time manipulating your auto track features, your manual track features, and making sure that you've got every single point in your scene is adding to your solve that you've got. So it is quite a manual process, and one that you kind of have to look out for different things that look like good features but actually are not. Some of them, as said, are really obvious, like these ones that are moving on our character. But I'll pinpoint, once this is finished, I'll pinpoint some of the ones that are also problematic, which might not appear to be at first glance. And then once we've kind of isolated some of these elements and deleted them, we'll try some manual track features and see how that's working. Because we need this to be absolutely bulletproof for what we need, for what we're using here, because we're actually sticking all of our geometry to very specific locations in the scene. Just also a note to how we sometimes use tracking within our kind of within full 3D scenes. We sometimes in our studio just film on a shoulder mount some footage within the studio and get natural camera moves with real cameras, track them, and then use those completely digital cameras within full 3D scenes. And that's something we do quite a lot for creating a more natural kind of camera movement, especially if we're combining that full 3D scene with other footage within our edit, so that we kind of have a seamless transition between something that's full 3D and fully filmed, using the kind of camera movement to give it a much more sense of realism. So it's not just used for kind of tracking objects into footage. We sometimes use it for actually just creating a more natural camera move for full 3D scenes. Let's just change our frame range here to match our what we've got in our footage. 340 to 650. We've always got our auto track features there. So let's just go in and manually delete some points. So we have to select our marquee tool. And then again, it's a double-click delete function. It's just literally going through and deleting the points we think are bad. And it's a preference thing, but we find this workflow much quicker, and we can be much more specific about what we're looking for. And we can leave some of the good tracking points which might have been deleted unless our mask was exactly accurate. And there are ways of importing very specific roto masks, but that you kind of have done separately. But again, rotoing to get that right takes a long time, and sometimes it's just easier to just go into the points and start deleting things. See, already I'm up a few frames, and that would have taken me a while to kind of get the Bezier right on all of the points. And for me, it's just a faster workflow of just being able to kind of plow through the footage and delete all the points that I know are wrong. it would have taken me just as long to edit all the points in the Bezier. Set my marquee. Luckily, they're not there for the whole shot. They're just there at the beginning. So this work is kind of minimal. You'll have to do at the beginning anyway, for this particular shot. And it's a patience thing. You have to be really patient with your scene. If you want a really good track, it will take a little bit of time to get this right. It's one of those things that's quite therapeutic. It's kind of like roto. You kind of get into it. You kind of switch off for a little while, forget about everything else, and just play with some tracking markers. So we'll continue kind of deleting some of these kind of points in a second, but just to kind of look at the footage and see what other points might be bad and why they might be bad. So a point like this, for example, it's quite straight. It's not kind of jipping around. Is that a good or a bad point? What this great feature down here is it's got a center view point, so we can kind of like always kind of mark on the middle of our tracking point. It allows us to see exactly what's going on when we zoom in. So just in the room or online, do we think that's a good point or a bad point, and do we know why? So the response is bad, and the reason why is because this is across two separate planes in 3D. This tracking point is tracking between this post and this and a point on this fence or door, which are in completely different spaces. So we can't trust the position of this point because it can be going up and down this this post here. So we definitely need to delete him, even though he looks good. Likewise, with any points that don't really have a fixed position vertically as well as horizontally, it's clearly not going to move. We can see down here. It's clearly not going to move horizontally. It's got a kind of box that it's sticking to, but this could slide up and down. And this is what I mean. It's a very manual process. Likewise with this, that's picking a corner which is definitely going to move. It's definitely going to move that corner. You can see how it moves. See, now it's much further up on that post, and now it's much further down. So we need to delete that. Great point is that you can see exactly what it's focusing on in this little tracking window down here. Sometimes you've got a tracking point which is good up until a certain point, and then it's bad. And the way you can kind of delete those is through the frame ranges of the tracking marker itself. So let's have a look at this point. It might be good all the way that we think. Let's have a look what he's doing. He's quite good all the way through. Let's have a look at this guy. Pretty good as well. Let's have a look at him. Okay, these are some quite good track points here. But if we wanted to kind of remove, say from when it gets too small and we can't really rely on the position of where it's trying to track to, we can press this remove before or remove after. So the remove removes the current keyframe. The remove after removes all the keyframes before on that timeline. And the remove later removes obviously everything else that comes later on. So we can remove before, and it's going to delete those keyframes from our tracking point. And this is really good because we might not want to delete the entire area of what's been tracked, but we do want to make sure that we're keeping the good elements of what's been tracked and deleting all the bad. So let's just continue to delete a few points from our guys. Turn off center view so we don't get our markers tracking around. we can do a super speeded up version of this in the video. Make me look really fast. How about that, Jeff? So again, also a thing to be wary of is that points that last for a very short period of time aren't really going to be adding much data, and they're just going to be confusing the solve. You want nice, long, good tracks. Like these ones there are only there for a very few milliseconds. You got this one there that's jumping around all over the place. It's definitely not doing anything for us. So it's going through and really cleaning up your file. So let's just make sure we get rid of all of our tracking markers on our characters. Let's go through it again.
So Paul, there's a question online here. It says, does one point affect the whole tracking if it's not correct?
It's good to go through with a fine comb and really analyze your track. If you leave one point in that really is a bad point at a crucial area, then yes, it will. But if you've got loads of other tracking markers that are good around it, it might be fine. It really depends on how many tracking markers you've got in your scene, and it's not always the more the better. It's just you want more really good tracks, basically. So if we feel like there's an area that isn't really being covered much with the auto track, then we can add in detail in that area with manual trackers. And often it's good to kind of solve the camera early on and see where the problem areas are, because then you don't have to waste time going through certain areas and deleting points when they might be when it doesn't need it in the camera solve. It's good to kind of only spend the fine detail of things when in areas that you know are problems. But I know that this is when you're kind of turning corners like this, and you've got tracking points which are like linking to what's behind the corner and the wall, and it thinks that that's a good point. It's not, and you need to really just go through and delete those points. Otherwise, the camera's not going to know that you're turning a corner at that point. Just like this point's a great example because it's kind of tracking the kind of edge of this soffit here, and it's flying all over the place in terms of the vertical position on that wall. You can see that it's climbing the wall as it turns the corner. So that the camera won't know, when you try and solve the camera, it's not going to know what to do at that point, so you just get rid of it. Likewise with points on cables, and this is a really challenging shot. It's not an easy shot at all. There's so many errors in this file. You know, he's quite still, this guy here. This is actually a little dude, but he might be moving, so we need to delete points on his head. So we just need to literally go through and see. But let's just first of all make sure that we've got no points on our characters, and then we'll just do a camera solve and see what are the problems of this scene so far. Let's just make sure there's no points. There's a couple more there. Turn off center view. I mean, what I'll be doing later as well is that even if you don't get an absolutely amazing solve on your camera, there are certain techniques that we can do to try and smooth out that kind of path. A lot of the time, even on the best scenes with the best kind of tracking markers, you still have to kind of smooth out your camera path in certain ways. So we've got rid of all the points for our characters there. Still a funny one there. So let's just do a solve on this. We still need to do loads of work to this, but let's just do a solve and see where the kind of main errors are kind of coming in and how we generate the solve. So we right click, we go to camera solver. Now we've got a whole new set of parameters to play with, and then we've got a kind of grid in the middle which represents our kind of ground plane. And then what we want to do is we don't have to really change anything here. This is just if we have multiple footages within our scene, which we don't really need to for this shot. Start and end frame 340 to 650, and it's kind of got the frame, the kind of focal length in there, 17.991. It's 18, but it's kind of guessed it at 17.991 from the distortion. And what we need to do is solve the frame. So if we just solve all now, we have these set initial frames. Automatic is going to read it from the start. We'll see what happens. Very quick, the camera solver. So we can see we've got a track shot here, and we don't quite know whether the points are sticking yet. At this point, what we can do is go into our multiple view, go to two views. We can actually see what that camera path is doing. So we can see where the errors are. You can see what looked good in the first viewport actually has some big problems in it. So again, the same controls as the other two windows. You see our camera path there. We can see we've got some jaggediness. But actually, within this section here, it's not actually too bad. We don't have it, there's no huge errors. Sometimes you get shots where the cameras have been kind of like flipping all over the place, but we haven't got that at least. So that's proved that we've gotten rid of most of our kind of bad tracking markers on our characters, and we just need to go through and smoothen things out a little bit throughout the process. So this is probably because we've tracked a shorter part of this shot, the most tricky part, but we haven't got such an error in our scene as I was initially expecting, actually. So what we can do at this stage, if we really want to kind of test whether how our tracking is going before we make any alterations, is we can add a test object. So we can kind of go to test object. We can click on a thumbtack and import that into our and add to scene. And we can change the interaction mode to place at selected feature, and we can plonk him in a place where we want to test. So let's put him on this step. Let's change the let's add another one. Let's put it on this roof. Let's do another one at the beginning on this door frame. Let's put another one in and put it on this kind of side element here. Okay, so we can see already, well, the point that we've selected for our first thumbtack doesn't quite match up at the beginning. It's kind of in 3D space. And likewise, the point that we thought was on the floor there is clearly a bad point. We don't know what that's tracking to, so we might want to go in and delete him, or select a feature in the room which we know is more reliable. Because that might just be a track, because we're working in 3D space now, that might just be a track that's not actually in that plane. That top one seems quite good, so that we know he's good. The one on that door is good. But the other two seem to be slightly confused on exactly where they are. So what looked like a good track initially actually needs to still have some work. Because even that point at the top there, you can see at the beginning, isn't quite in the right plane. But it's good to kind of have these in there while we're kind of testing. So let's go back to our auto track, and let's look at a few more features that we might want to delete. Again, all these side elements, let's make sure we get rid of those. And we want to make sure we've got a clean auto track before we add any manual trackers. Because manual tracking can sometimes take a long time, and we don't want to waste our time in areas that is not needed. Some of these points are quite good. Some of them are definitely not. Like, we don't know that this cable is exactly underneath this this thing here, so we need to delete that. I mean, actually, we can see that it's actually not. Likewise, when cables intersect. Let's just scan the scene for any of the problems that we think pop up. Again, that cable intersecting, cable intersecting, cable intersecting. These points are good. The ones that are actually on the edge of something and they're clearly within the window, not going to move about. Anything that's not attached to a kind of fixed point and that have a reference like this, where it could slip along that point, it's good to just check. He's kind of attached more to the hinge, so he's okay. And again, this center view is really great for kind of checking all your tracks. So again, you can see this one visibly slipping. And he's very short. He's a useless track. A lot of the ones on this gate are fine because that's a fixed thing. It's quite contrasting. We can leave those in there. But again, anything that's kind of along in front of that and attached to it, we need to delete. All the ones on the left there are good. We have a moving, dancing one here, which we want to delete. Dancing one there. And again, when you're deleting all these tracks, it doesn't necessarily mean the solve is going to be any better because you've got less data to work from. So it's that combination. He's rubbish. It's that combination of kind of good accuracy and amount. And if you haven't got enough once you've deleted, because you have to delete so many from a shot like this, when you've got a huge amount kind of covered by our characters and then lots of kind of intersecting surfaces, then you might not be left with enough tracks to actually, for the camera to be able to understand that solve. So that's again where the manual trackers come in. Okay, we have another quick question in the room here, so we'll just get the mic.
I was just wondering when you the reason why you're not working with mask, because you don't want to redo the auto track again and allow it to refocus on the amount of points on the...
Redo the auto track what, sorry?
Yep, I thought the idea of using masks were that you would refine it like you're doing now, basically, but you would refine the mask instead, and this way you could redo the auto track.
This way you don't have to redo the auto track. The auto track, you've already created the auto track, and you're just deleting the points that are tracked. So it's a preference thing. You can either create a mask at the beginning and then auto track, and then it just doesn't take into account anything that's inside that mask or outside the mask. You can invert it. Or you can just track it and then just go through and delete the points like I've been doing. For me, for most of us in the studio, we prefer just manually going through and deleting things, just because it takes quite a long time. Actually, it looks really quick to actually just generate that mask and to track it in, but it can take some time to get that bezier to be kind of tight enough around your character that you're not ignoring some good points, basically. Because I need every point I can get in a shot like this. I don't want to ignore points that are maybe good, because I know I'm going to be limited by a very few amount of points. So for me, the most detailed way of tracking this shot would be to delete all the points within the characters manually. And I know it's only like 200 frames or something like that, and I can do that, I think, equal to, or if not faster than creating that mask. And I think the results are more accurate because you're deleting very specific points, basically. It's a preference, you can do it either way. Some people create really complex roto masks and then import those and then have that separately. But for this, it was just as easy to kind of delete the points, basically. So, but you don't have to retrack now that you've deleted those points. You just have to resolve the camera point, and that's how you get the camera to be more and more accurate, is to keep going back, altering the auto track, adding manual trackers, and then resolving the camera. Does that answer your question? So let's just have a look if there's any other points that we are struggling with. And we can see visibly. And then we'll do another solve and see if that's changed anything. Again, we might get unexpected results because we are deleting a lot of trackers here. So we might not have enough data to generate our solve properly. I mean, this one's, what is this actually tracking? Nothing. Yeah. So it is a very fine comb operation when you're kind of dealing with tracking markers and points. But the results kind of speak for themselves when you do spend enough time on things. And the thing is with tracking, it's either right or it's wrong. It's not kind of right. As soon as your kind of model slips, you've lost that illusion that you're trying to create when you add digital elements to real footage. You have to keep the audience completely fooled by what you're doing. You can't have a moment where they realize that it's digital fabrication. Again, this one's slipping. Some of them are more obvious than others. This one's dancing around. And you can already see points when you wish it was tracking, and you can kind of go through and manually track those. That one's slipping. There's a huge amount of errors in this scene. Again, sometimes you do get lucky. Sometimes you track something, you auto track, your camera solve, and it's done. And then you can rejoice because you don't have to spend 3 days doing it again. Again, this whole shot, we probably spent 2.5, 3 days on this track shot. You know, one person, 2.5, 3 days, getting it right. It's not something that when you do it properly is easy or quick. One thing to kind of remember is sometimes there's different kind of levels of kind of production for these kind of things. The highest level of production, if you're working on Iron Man 3, they will digitally scan this area, and they will have a completely one-to-one accurate model of your scene, which they'll kind of simplify and create their own version of, and then they will essentially using lots of different methods that I really haven't explored much, but you can import your model and use that as a base for the solve, so that you're working from completely accurate digital information to aid in your tracking markers. That's the complete high end. Well, and then there's kind of another process still, like Cloverfield, for example. You've got digital tracking markers which are read by lots of different cameras in a scene, which will then kind of give you position data no matter what you're doing with your camera. Because if those of you who have seen that film, it's all filmed on handheld, and there's no way they could ever track that like this. So there's different levels of production with these things. The kind of next level is to kind of measure everything and create the model yourself, and then get all texture information from photographs and model up a completely digital version of this based on the old school measure and photograph methods, and then you can still use that. But for us, we didn't have that opportunity. We had to get in and out of this space quite quickly. This wasn't a closed area. This was us, with a few local fixes trying to stop people walking in, and we didn't have time to kind of measure and photograph everything. So you're stuck with having to do everything in post-production, which is most of the time you'll be in that situation. So I think we've cleaned this up quite a lot now. Let's just have a look at some of these. A good thing to note if you're kind of working with a lot of distance things, you don't, although there's something, these points are probably okay, but if you've got things that are very far in the distance, you want to delete those. If you've got things that are in reflections, you want to delete those, like reflective points. That, again, these are all things that fool you into thinking that the points are okay. But reflective points, obviously, you want to be getting rid of. We've got no issues with reflection in this scene. But some of the points, like if we had a point down through here in this space, we'd probably want to delete the ones that are in here, because that's in a completely different plane to this building here, and the camera might not read it as such with a camera move as subtle as this around that corner. But that's actually like, 20 meters away from this building. So those kind of areas we want to kind of delete. Intersection. So it's just knowing what to look for. Like, you can see straight away when we're looking properly, this point again is not a good point. So out of interest, let's do another camera solve now and see where we're at once we delete. Some of these foreground ones are going to give us some problems. Getting kind of parallax in the foreground is good to have. And because we're not picking up much of this foreground stuff successfully, that's where we might want to add a lot more manual trackers to in a second. I can see some of these points visually moving. We'll just create those again ourselves and know that they're fine. Because we need these foreground ones to really give us that head start of our track, especially when we're generating, we're solving the kind of track from the beginning of our footage. So the beginning bit is really important. And there's ways that we can kind of like cheat that, and I'll show you that in a second. So let's just, any super obvious ones we'll delete, and then we'll continue. Okay, right. So let's go back and let's.
Hi there.
We have another question?
Yes, I have a question about if you do have time to plan your shot, are there types of objects that you can set in your scene, like green balls or something everywhere that the software will be able to track?
Yeah, on a lot of the scenes for this film, we had kind of green tracking markers on tape with into a cross shape with a black mark in the middle, and we'd paste them everywhere basically. This wasn't one of them because there's a lot of texture on the buildings, there's a lot of points that we can see, and yeah, to do that, I mean, we were confident we could track this shot. Basically, is the kind of ins and outs of it. We'd done a little bit of tracking for a while, and it was kind of, we were confident this was one of the shots we would be able to track without tracking markers, and the work that had to go into the track was less than the work that would have to go into painting out those markers, basically. And that's the decision you have to make when you're setting up a shot: is which is the most work and which is the most expensive, basically.
When you use that method, do you have to apply quite a few of those pieces of tape everywhere, or?
Again, it's hard to say how many you really need. It's different scenes are very different. It's more having some in the right by the camera as you're moving through. So we might put more on these walls here on the side to give us that parallax as you're moving through. They'd be really important. We have a door here which is quite good, but on the left there's not really much. So we might want to, if we were going to do this, we'd probably put some points there. Because most of the points it's kind of picking up are on the edge, and they're not the ones we really want. These edge points, because they're kind of conflicting, because they're in different kind of parallax. So yeah, we'd put them in the areas that are going to give us the biggest head start. We wouldn't really bother with putting them further out into the space. One, because we've got loads of detail here, giving us lots of information, we think. And the other one is, it's mainly the initial areas that we need it for, that will kind of generate the beginning of that camera solve, basically. It's not like it's not like a number, you might have 6, Right, let's continue on with this. Let's have a look at our camera solver. Let's solve all again. Let's have a look at what that's done to our path. Again, we've got a few jaggedy movements. The path is overall straight. I'll explain how we can kind of smooth that out later when we're slightly more confident with our tracking points. Now we've resolved that, our test object scene is irrelevant, so we can need to delete him. But it's just good to see where these points are and what's happening on the timeline. So we can kind of scroll our camera, we can see at that point there's a wobble. So clearly there's just nothing it can read here. You know, we've got our guys right in the foreground. We've got no foreground elements that is really trackable. So these kind of areas are the ones where we really want to focus on with our manual trackers. Because it looks like it sticks. And if we orientated this scene and put a few test objects in, it probably wouldn't be half bad once we smoothed out a few elements. But it's just, as soon as you see that wobble, that little wobble, you've lost the illusion, and that kind of difference between digital and reality is going to be a lot, really evident. So in between our auto track and our camera solver, we'll detach that. We'll add some user track features, and then again, we double click on that. We've got our edited GI or edited curves that we're doing through the graphics card. So we can do the same thing for our user track. Go down to enhance, colors, and then I need to activate my display LUT, and then I can activate it there. But for this one, I'm actually going to do more of a custom one because I need to pick out more of these foreground things. I'm going to try and get more texture in this foreground area so I can have a slightly better tracking points to use. So I think we have a question online.
Yeah, there's a few questions here. First one is, what cameras do you recommend for tracking correctly? Red, Alexa, Canon, RAW files, or compressed?
It really depends on what access you have, really, to be honest. If you're in a big studio and you have budgets to buy big cameras, we've used the Red Epic and Arri Alexa. I think for us, our small experience in high-end cameras is we prefer the Arri Alexa. We think that it's much better for nighttime filming, particularly, and it's kind of becoming a really respected digital camera in the industry. I think Prometheus was shot on the Arri Alexa, and it's becoming one of the best digital cameras out there, really, for filming. But if you're doing kind of more your own things and your smaller budgets, then 5D Mark III is kind of like, it's really good to get one of those. Have a bit of kind of knowledge about what the sensors are doing. Obviously, the 5D Mark III's got a kind of full frame sensor. If you want to do kind of slow motion stuff, then 7D is always good as a kind of cheaper alternative, but it has a crop sensor so that your image will be cropped. And for those who don't know exactly what that means, it's let's have a look here. Let's have a quick look where we put that folder. Let's have a quick look. We've got some examples of some of the HDRIs we took, and it makes a difference when you're taking mirror ball photos, which we can talk about a little bit as well. Let me just try and find the in MISC, in Girl Sound Particle Files, in VFlow, HDRI stuff. So basically, when you're taking HDRIs, this was the HDRI we used for that scene, and this is a kind of full 360 frame HDRI. And when you have a cropped sensor, you won't be able to take pictures like this. It will essentially be cropped. When won't be able to illustrate here, but you won't have a full circle. You'll have a kind of cropped top and bottom. And that's fine. You can still probably create the same thing. It won't be a completely 360 degree image, basically, or 180 degree fisheye lens, which is what this was taken on. And we use these at 7 different exposures to create our HDRIs, basically, for the scenes. So this was captured with a nodal ninja and a promote control on a 5D Mark II. And then you can use several different ways to then make that to combine the images on each quarter side of the location that we're taking in to create the HDRI information from. And then you can combine those images into one big panorama, all within Photoshop. So these are the different exposures we've got for the different sides. And we're not too bothered about this people walking through because it's not really going to affect the light data. What we need is this data here, intensities. The different exposures give you that variance. But for filming, 5D Mark III, 7D for, actually I think the 5D Mark III does have 50 frames per second now actually. The Mark II didn't. But you can see here we've created this curve which is giving us a better kind of view for our foreground. We've got loads of texture on the walls here. And this is kind of why we didn't do tracking markers, because we've got all these points here we can kind of reference. So let's add a user track, go back to our parameters. Let's create. And let's just start looking at a good area we can start with. Let's take this guy here. So what we've now got is 2 boxes. And this is kind of like a fall-off zone for how far it should kind of read its surroundings. And then this is the hotspot zone, which it should try and keep everything that's within that static as possible. And you can see what the window's doing here. You can kind of see that it's kind of is zoomed into that element, and you can exactly see where it's caching. And it's catching the pixel, sorry. So we can center view that. And then again, we have a few options here. Just scroll over and it tells you what most things are. Track forwards by 1 frame. Track forwards until it errors, basically. And then minus and minus errors. And then there's different ways we can kind of delete forward, delete back, polish what we've kind of created, check out things in the curve editor. And so if we just start kind of auto-tracking this feature here, you see it stopped there because it kind of got to a point where it feels like it's errored a little bit. So we just kind of continue it. And then when it gets to the edge, we're going to manually move this until it kind of falls off frame, and then you can see there that it's actually dropped. It's actually slipped a bit there, and then it's dropped off. So we want to go back to the frame where it was good, and then we want to remove the keyframes. But then then the tracking marker will just stay there. So what we also want to do is hide the tracking marker, and you have to double press, and then it will disappear. It won't be taken into account. Again, we'll go back to the start there, and we'll start tracking backwards until missed it there. So then we kind of remove backwards and hide backwards. Double click, and then we've got our little camera track there, which we know is solid, better than most of our auto track features we've got. And what P-FTrack does, it takes preference of the user tracks. It creates a kind of a hard constraint with the user tracks, and it creates a soft constraint for the auto tracks. So sometimes you can get a full track with just user tracks. If you just think, right, I'm just getting no luck with my auto tracks here, I'm going to spend half a day and I'm just going to kind of add loads of user tracks in places where I think it's going to give me enough parallax and information for my camera solve. So I'm just going to fire a few of these in and make sure that I've got a few more in the foreground to be able to give me more information at the beginning.
There's another question online here asking whether or not you recommend Steadicams for shooting moving action or a shoulder rig.
We've done a few things. This was shot on a full body Steadicam, but we also use shoulder mounts. We also go even more minimal than shoulder mounts. We can just use a stand for a small tripod and put it just underneath your arm, and it gives you, because we do so much stuff without permissions and run and gun, you kind of have to be as kind of minimal and light as possible. So we often use as little tech as possible unless we need to, unless we can get permissions for. But this was shot on a Steadicam, and that's why the movement is so smooth. So it really depends. Steadicam footage is really nice, really smooth, and it can kind of like be less jarring if you're blending with full CG shots. If you've got kind of these handheld moving shots that are kind of going all over the place, and then you've got these really smooth digital camera shots, it can be very jarring if that's in the same scene or same animation. Whereas if you've got a really smooth camera for your footage, then it makes that transition a little easier when you're kind of using artificial cameras in 3D. Center view. So this one's a great one. It's lasting a long time, and it's given us a great point of reference to use for hide forward, because it's going to go out of frame. Go back, and we'll try and get a bit more out of this guy at the beginning. All the way to the beginning, which is great. Again, we just need to check our frame ranges here, because it's kind of adding more than we necessarily need to. Let's have a look. Oh yeah, we can see our errors here. We can see exactly what it's doing, and where the errors are kind of happening within our auto track features. But again, there's ways to kind of smooth that out in the graph editor, which I'll show you in a second. So let's try and add a few more features in the foreground at the beginning on the left. Now we can see this wall a bit better. And again, you wouldn't really have this range on a 5D with the JPEG compression unless you've got different systems that allow you to export RAW through 5Ds, which we've experimented with. But let's add a few more, some of these key points. So this one actually doesn't last very long at all. But even though he doesn't last very long, we know he's a good one. And we need a few points there, no matter how short. Okay, so we've got a few camera tracks in here now. We'll probably add maybe one or two more to the floor around here. See, it's gone off there, so let's just hide forward. Let's have maybe one more on this side, because we get some good, some long ones here. Whoa. So let's go back. Make sure we delete forward. And in cases like this, when his head is kind of clipping it, but we might find more frames later, you can manually move it so it doesn't kind of flip off. So if we kind of go forward a frame, it's lost it. But within this window, we can kind of bring him back. And you see it kind of continues the curve. You're manually moving that curve when you move these trackers. So we can know that when we put that there, that's roughly still in line with that curve's trajectory. So again, center view that, and then let's just add a few more so we can get a bit more out of this track than we thought. We didn't have to cut it where his head just meets it because we've manually moved that in place. again, let's move there. Let's move him back. So we can cheat the system a little bit by manually saying, no, it goes here, it doesn't quite go there. Until we get back into a frame where we can auto-track it properly. See, now we've got a few more frames out of this guy here. It stopped again there. And there's no real point continuing it from there, really. So we'll go back, hide back. What that does, though, when you add manual points like that, sometimes it can create, this is going to reflect in our kind of camera path. So we really want to kind of go through here, really, and just manually adjust these a bit more so they're in line with what we've auto-tracked. And it's a subtle change, but it all adds to the kind of solve. But then also we can press this, when we kind of change things like that, we can press the polish button and then it will kind of generally smooth things out slightly. It's good practice on all your manual trackers just to click the polish button, just to kind of manually smooth out some of the points. So let's see if this is actually helping us a bit with our track. So you've got this point which doesn't stop there, so we need to make sure he actually deletes or hides forward. So when you get those floating ones, they're just going to completely ruin the track if they're just floating there. Your solve will take them into account. Again, this tracking marker here, you can see he's floating, so we need to delete wherever he stops forward. Or continue the track until it stops. Hide backwards, and then he is disappearing. Okay, so let's have another go now. Let's solve this camera again. Solve all. So now it's taken into account the user track and the auto track. And we can see here already that's giving us a much smoother beginning because we've added all those user features in, basically. And we can continue adding and smoothing that out, but that looks okay to me. So if we just have a test, it looks way more solid now. This was kind of coming off the side of that platform as we move through, but now it looks a lot better. And to be honest, we do want to continue adding user tracks to some of these areas. What's also useful is adding user tracks to corners of things. You have references for modeling later on. But hopefully this is kind of giving us a good-ish track. Good enough for this tutorial anyway. So we can continue looking at some of the other features of P-FTrack. But if we want to make this track better, I think still the foreground needs a lot more work in terms of adding more detail to adding more user tracks. Because I think we are getting still a little bit of slip at the beginning. It's probably good from here onwards, because that's where we've kind of added our user tracks to the foreground area. But if we had more time here in this class, we would definitely add more points to some of the foreground elements to get that beginning really good. Now, because we're not 100% convinced with our beginning, we don't necessarily want to set the initial frames automatically. So if we uncheck that, we can say, actually, I think that from frame 406, if you press this S, it automatically kind of attach it to where your timeline is, to 500. I think that's a better frame range to start because I'm more confident in this part of the track. And then you can solve the camera for this initial solution only. So we solve that. So now we've got to solve. Sometimes we have to delete our camera solve because it's still got the information from our last solve in. So if we add another camera solve here, we'll leave him for now. And we set our initial frames here. Start and end frame is still 340, although we won't be using that frame range. for the solve, for the initial solve. And we solve for the initial solution only. So it has failed to solve that initially there. So it did rely on a bit of that information at the beginning. So if we give it a bit more of a frame range, we'll just ignore the first 20 frames maybe. So 320 to say 550. It didn't have quite enough to go on there. Yeah, so it does rely on a bit more information. It needs a bigger frame range to actually to use that. But when you have a longer shot like this was initially, this shot obviously continues much further down, then it's wise to kind of solve initially from the initially solve the solution from a part of the track that you're very confident with, and then extend the footage from there. So if we set our frame range to be from 340 to 450, then we can basically, if we just go back to our beginning, let's set for initial frames because we're only working with the first 100 frames or so. Let's solve that. So let's solve this initial bit. And what's good practice is kind of solving things in sections, going through and changing your frame ranges and making sure each section is working for you individually, and then you can solve your entire solution in one go. But it's good to then go to the next 100 frames, select your endpoint, and then once you go back into the solved area, this extend button will be available. And if you extend that, you can see what it's doing if we go into our 3D view. So we've got a nice smooth curve there with hardly any errors, apart from just slightly there. We can press extend, and it's extended our view to frame 550. We've got a bit of a slip there. We can then go to the end, press to the end, go back into what's already solved, press extend, and we've extended our profile even further. So we can kind of test things separately, so we can make sure that we're kind of extending our solve rather than necessarily doing it all in one go. And that often works for complicated scenes where you're kind of like, you're using part of the track as a reference point for the other parts of the spline to be kind of using as a reference, and you can extend back and extend forward, and that's kind of a way of solving tracks which are a little bit more difficult to track. So let's just solve this in one go and see how we get on. And then we can kind of talk about some of the other features. So good. One point to actually say before we do that, if we attach our initial solve here, there's other ways that we can kind of there's other ways which we can change and improve our user tracks by ignoring some of the bad points. So if we just solve all again, see our camera path there, which is working fine, we think. But then if you go to errors here and fit view, you can kind of see that we can trim our footage or our errors. So you can see here that there's actually not too many massive errors in this because we deleted loads of points. If we did this at the beginning, you'd see loads of points. But there's still a few spikes, and you can kind of take this down. And the temptation is to rely on this and not delete all your points. Whereas what this is going to do is completely delete the points that you've got, rather than necessarily deleting frame ranges that you know that some elements are good. So we can use this, but don't rely on it too much. And sometimes we don't use it at all. Generally, you want to be under 5 at least. But the lower you can go, the better. But what you don't want to do is essentially take it down so low that you're kind of like, this line is becoming both too erratic, but then also where if you get any of the white area spiking up outside of your trim range, then it's not going to be able to solve your camera. So I don't want to trim too much because I'm happy with the amount of errors that are in this. I'll leave it on 3.5, say. And what you can then do is refine your solve. So let's see if that's a good thing or a bad thing, where we've kind of taken out our some more of the errors. So we go to refine all. And it's generally smooth things out a little bit, which is good. So we'll leave that amount on. The other thing we can do to smooth out our camera path before we go further is enter the curve editor, and then we can see we've got the translation and the rotation, and that is relative to our camera path. So we can see now we've got a path here, which looks pretty decent actually. Normally you see a lot more errors in this. We go to our file here. You can see that there's a slight kind of bump there. What we can do, which is really awesome, is just select a bunch of keyframes and then go to smooth. We can kind of keep pressing that until it smooths things out a little bit. And I'll kind of try and illustrate that. If there was any more kind of spikes, I might manually move one of these elements and show you. It kind of smooths things out. So if you have spikes like that, you can get rid of it very easily. So let's just move these down, or rather, press Control Z. Let's just manually move those down. Then we'll smooth that out as if it was a real spike in our footage rather than something I've just messed up. Smooth, 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 smooth. Just keep pressing that. Another option, if you can't get the level of smooth you need, if you've got a really big error, is to select a bunch of keyframes and then press simplify. And that will simplify your keyframes so that you can then smooth even further if you've got large errors in your scene. I'm just going to copy this script just in case anything happens again to this file. Just going to plonk him here. Again, we don't normally have to do that. It's the first time I've ever lost data in P-FTrack, so hopefully you won't have a similar thing. Okay, with my little error there, with my adjustment there, we've got a little bit more of an error than we had before, but that's fine. We can ignore that because that's something I've just done. Normally you'll just try and solve errors, not add errors like I've just done. It's very rare that you'll try and add errors to a P-FTrack, unless you're doing a tutorial. So if we're happy with this, we're happy with our curve. We've kind of spent a bit of time smoothing it out. We go back into our node view. So let's just see where we are here. We've gone activate our tree back, sorry. We turn off our curve editor, go back into tree view. And then what do we want to do now? Test objects, we can do test objects. We also want to orientate the scene first. So let's orientate the scene. And then there's lots of ways you can orientate the scene. The most popular option is with axis, and then you kind of set your X, Y, and Z. Unfortunately, there's not really a space where I can rely on, which has got a square reference in this picture. So I'll probably just use the normal standard rotation, and I'll move this manually in place. But what I will do is try and find a point I can use as an origin, maybe this point here. So I'll select my marquee tool, select that point there, set as origin, and then that's a good kind of base point for me to then start moving this into place. And again, if you've got a slightly more standard scene with a bit more square surfaces, you can actually start lining up your scene with the axis tool, and you'll just start lining up those lines with the surfaces X, Y, and Z. It's pretty easy. So this doesn't have to be perfect because we can adjust this in 3D when we get in anyway. But let's give it a little bit more of a head start. It's quite sensitive when you're looking right at that area. So we might want to work in our view here. So anyway, again, we can tweak this in 3D later on. It's just to give it so that the plane isn't facing completely in the wrong direction, basically. The reason why the axis is better is it's much more accurate to your scene, but we just don't feel confident in some of the points. You can definitely get the Z. It's more this building is on an angle here. This wall is completely different, and that's gonna play with your your setup of your scene if you haven't got an accurate square reference. So we've orientated our scene. What we now want to do is put some test geometry in, or some kind of image modeling. So we've an image modeling node here. We give us loads of options to play with. And again, we weren't 100% confident with the beginning of our track. So but we'll try and put an object within this thing here just to see how it's kind of lining up. So we put one of the primitives in, which is a square, and then we want to be able to move this, but we can't move anything at the moment. So we have to go to vertex editing and press move. So then we can actually move this into place. And what this is doing, you're not actually distorting the image at this point. You're just moving in 3D space, which you can see on the right, where that geometry actually is. And you've only done it for one frame, so it doesn't necessarily mean that that's right. So you have to move a few frames. And this isn't a great example because it does go off screen very quickly, but if we say move to there, then we move a few of the points around, we can see that it is actually moving it in 3D space. So you can see that we've kind of lined that up, but because we haven't got enough of a reference point over a number of frames, it's going to take a few attempts to actually get that to stick. Normally you have to do it 2 or 3 times, but now that's sticking in the right place. So you can see it here in our 3D view. So we don't have to add too much. We want to give the person, or if it's the same person in our case, a kind of hard time of rebuilding this scene in 3D. Then we want to add a few more kind of reference points digitally. So again, we've only got a few frames to play with for this window here, but we might want to add another window. So let's locate our, we generated this guy when we're over here. So let's just delete him, move frame, and then add in another object here. It still added it over there, which is a little bit annoying. So let's try and move him where we can see him. Let's just delete him again. Let's select off our square, click again, and it'll put it in the middle of our scene rather than referencing anything we've got selected. Let's manually move this guy. Again, it's kind of like, it's quite interesting to see where it thinks it is in 3D space when you move it, because it looks like you're kind of transforming the image, but you're not. You're just moving it in 3D space relative to the camera. So it'll take a bit of time to kind of adjust these things properly. There's a kind of a bit of resilience to it while it's kind of fighting with the software to understand exactly where that is in 3D space. So it can take a little bit of time depending on how good your solve is. And this is kind of indicating to me that my solve might not be 100% accurate at this point because it's fighting, the software's fighting with me when I try and put this in place. And you kind of see it fighting here. It's a bit confused on this object. It's kind of getting there, but it's having a hard time Trying to remember these points, and whenever I move one point, it's moving another. So it's almost there. Okay, it's almost there. And then again, we want to move a few frames and try and position that in. That'll kind of move it relative to the camera. Okay, so hopefully that should stick a bit better now. Still want to probably play around with it here, but again, the disadvantage here is that we can't see the end frame, so we'll have to almost kind of guesstimate it here. So you want to pick objects that you can really see and rely on as a good reference. Okay. So once you've got a few images, a few kind of planes in place, a really cool feature of P-FTrack is that you can actually extract the textures. So again, if you don't have loads of photographs taken for your scenes and you can't texture it yourself, then you can just take textures from the footage, and it has really great ability to, so if we click on this square here, if we look at a frame where we can see, if we take the UV projection and put it on the camera and generate, what we can then do is paint that texture in on that object. And we've actually created a textured plane here now, which we can then, when we export it, we'll have all that texture information. And why do you really need to build the textures? I mean, for us, it's you need to rebuild these things for reflections and for the light to bounce on it properly. If you rebuild your geometry and everything's white, what you're going to be merging into that scene is not going to be kind of reacting correctly to the kind of material that's in there. So you need to at least get the diffuse color data correct. And we don't actually, this is like, oh my God, I'm going to have to rebuild all of this and paint all these textures in here. But there's actually a slightly different workflow which we do again with camera projection using the animated footage onto the geometry. And I'll try and explain the kind of benefits and limitations of these things, because again, the kind of high-end workflow would be to photograph and texture everything, and then you have that. So you don't have to camera project and you don't have to texture extract and paint your objects. But these methods are kind of used if you don't have the ability to lock down an area for an hour or two and take photographs of everything. So this allows you to quickly kind of paint and texture your objects. So we can do the same thing with this guy here. Let's click on our other square. Our UV projection is camera. We are clicked on that square, yep. We click on generate, and then we can literally just paint this in as well. But you can see in this one, we've got his hand in the way. But what's great about it is that you can actually just move frames and then repaint that bit in. So it's a really nice, really cool feature that P-FTrack has, and you can see how that's kind of working and where it sits within the scene. And then basically, you can see these maps if you go to Edit UV. And then you can see exactly what it's doing. And you can kind of, there's different things you can do. You can fit UV, which kind of like stretches the map out to kind of better fit the square. You can change the resolution and the dimensions of that thing to best represent the kind of size of your texture. So I'll close that now. I've actually made that bigger, so I need to go back and paint again because I've made the UV size bigger. So I need to repaint that element back in. And then you'll be able to see that in Edit UV, I have, it's up to date. So once you're happy with your track, you're happy with your camera, you're happy with you've added a few images and you've extracted the texture, then what you want to do is you want to export your scene. So how do you export your scene? You add an export node, of course. So then basically you have a few options here. Now you don't just want to export your model or your kind of a camera solve. You want to export also your distorted footage, because you need to use that in comp. So the first thing that I do is in clip export, you check your clip and you export, I can't create clip, you export your clip, but you have to, let's just have a quick look here. You have to edit your settings. So we might select our folder. Put it in superseded, call it CG school clip export. You have to actually just choose the folder. Then you set the name here, sorry. File format, make it EXR, so we're not actually losing any data at 32-bit. And again, there's no codec with EXR, so. And then we will close that. And then we'll export our clip, and it'll export our clip to that folder. So we want to export the EXR, but we also want to export a JPEG sequence, because we don't want to have to load a EXR sequence within 3D Studio Max. That's not what we. It's not going to be very quick to work with. So we'll cancel this, because it's going to take a while exporting that that EXR. But then we will. Oops. Let's go back into the setting of this, and if JPEG's quicker, then we'll do it here. If not, we'll do one that I did before. Let's try JPEG. And let's just see if this is going to kind of export much quicker. Okay, this is a bit quicker. So while that's kind of happening, I'll talk about these other elements. You can export the lens distortion, which we actually didn't do for this shot, to be quite frank. But just so you know, we need to kind of somehow get that data back that we've kind of used to export that footage, that we can then use later on in composite to redistort our renders and our footage all together back to the original frame. So we'll be using this distorted footage in our 3D comp, but then when we bring all our renders back into comp, we want to be using at the bottom of that tree, we want to be kind of re-distorting our footage to the original camera parameters. And over here, this is where we kind of export our FBX. And this exports any kind of model data that's been made, the tracking, the trackers themselves, the camera, as well as the textures that might have been painted onto the scene. So it exports everything. So once this clip is exported, we'll export our FBX. And we'll bring that into Max, and we'll see exactly how that's working. And then I'll show you the scene that was created from that file. So let's kind of export this, and it has lots of different options that we can kind of use from my Max, waveform, Nuke, Python script, if you want to bring it straight into Nuke. But let's just select FBX and try that. Let's put it in. Let's make sure we're using the right. We want the E drive. Export. New folder, just in case there's anything else in there. Call this CG school track export. So it's automatically given the default name of our footage, but I know we're kind of using codes for our shots, and I know this is TRA30 export. Or P-FTrack export. and the scale of the scene is 1. Again, you can play around with this because there's no real. The only way you can kind of resolve this in here is if you've got any reference geometry that you've made that you know is the right scale, but here we don't. So all we need to do is export the clip, and then we can deal with the scaling issue in Max. Export succeeded. Always suspicious when you hear noises. It's like Homer's "everything is okay" alarm. It's a Simpsons joke. So let's extend our scene here. And what we want to do is we want to import that file. Export, CG School track, and nothing is there. Why is that? Let's have a look if we definitely exported it on E. No, nothing's in there. So let's just make sure we've exported this correctly in P-FTrack. Or if it's default, save somewhere else. We can see that it's actually saved on My Documents folder here, rather than where we thought we set it to. So that didn't update when we pressed, we must have just closed it rather than press save. But it did actually save out within here, just not quite in the location we thought it was. So make sure you press save rather than making errors like I did and just pressing close on the tab there. So let's go to that folder location. Select our FBX. It's going to give us quite a lot of options, but let's just click OK and see what brings in. Tiny, tiny scene. If we bring in, we select one of our objects, we can see that what we've got here. And the reason why is that we've got a few tracking markers that are literally light years away, and that's kind of why we've got some problems here. Let's just double check our camera group. What we might actually want to do is, I always forget, we might want to export this as a Max script. I don't know if actually FBX works properly actually. I think we've always used the Max script. My default was to go to FBX, but I think it's actually, you load it as a Max script and then it loads the camera data from that. So if we try that again, let's just select a proper location for it this time. So let's copy that, paste them in here. Open. See, it hasn't saved the export path for some reason. Okay, you have to name it. So let's export the scene as a Max script. There's no other Max script to choose apart from 2011. Let's export that again, take 2. Let's create a new scene. And let's run Max script. Let's find that location. And we can see here now we've brought in our camera and all of our tracking data, basically. It's created keys for the entire clip because our entire clip was much longer. Our original footage that we used. So we can just, because we've only done this as a test for our tutorial, we can limit our frame range to be 648 as it is here. Delete a few keys and just make our timeline 648. You also want to check at this point that you're in the right time configuration, because for us we obviously use 25 frames per second, and you want to just see what that's doing to your frame ranges. So it's automatically changed me to 540. As you can see here, we want to make sure that everything is within our clip. So what we want to do is obviously import our footage in the background. So we'll bring in, we'll go to Control B, or Alt B rather. This is changed in 2014, but I'm sure we'll be able to find our footage. There we go. This is slightly different. Let's load our JPEG sequence. And display background. Again, this is slightly different to one I've used before, but should be the same. There's normally a show background in 2012. Does anyone know where show background might be in this new 2014? Oh. Seems to have popped in. But out of interest, where is it? Just getting some help from the audience here.
The plus sign at the top, I believe, the viewport, left-hand corner of the viewport. New computer viewports. And then it's going to be background.
That's the same. It's the same place. Yeah. Normally there's like a view background option where you can kind of uncheck and check. Is that moved now in 2014? Right, I guess you just switch between these to turn that on and off, I guess. Well, it's just a slightly different workflow. Okay, but what we do want to do is make sure that we're starting our map at a certain time. So let's just check this, because it clearly is not starting quite at the right time here, and it's exported the entire clip. Whereas we had a very specific frame range. So we want to kind of go into our viewport and then start tweaking with this. We wouldn't have this problem if we exported exactly the same clip as we tracked, but because we tracked a different frame range, we need to kind of offset our footage a little bit. Let's just see if that is actually changing. So that's kind of gone back from it. So we want to start this. Let's make our viewport start at 0, so we can see what's going on with our background. Now I'm not appearing.
Instead of dragging the timeline slider, actually try clicking on the arrows on the slider, and it sometimes forces it to update.
I use the curve editor a lot when I use with backgrounds, because it kind of allows the viewport to update with the slider. If you kind of move the slider on its own, you're just moving the model, you're not moving the background. But in the curve editor, you're actually moving the background as well. So it seems to be starting from there. Let's just double check our export to see if we've got what frame it's actually starting from. So you can see it's actually starting from the wrong frame range. And this is because we essentially had a custom frame range in our viewport that we were working to, which was different to our clip. What we really wanted to do was start from how that synced with our the frame range that we're working with in P-FTrack, the same as our export. So what I'm going to do is bring in the one we did before. So load this one. And the distortion might be slightly different on this one, but you'll get the idea. So if we go to the background again, load our previous sequence, press OK. Let's just double check this. And again, this was generated from a slightly different track. So let's offset. See what happens when you start it on 0. See here, it's not kind of matching up just yet because we need to kind of make sure that we've exported the right frame range. This will take a little bit of tweaking if you haven't, if you're, again, your track that you've exported from P-FTrack is on a different frame range from what you're actually exporting. So this is kind of starting from frame 340, but our original frame range of our footage, if it will update, P-FTrack taking a little bit of time again. Just it's important to be on top of your frame ranges for the kind of export of these things. Let's just double check our curved footage. See, we actually worked from a completely different frame range in our original track. We didn't actually see the foreground elements, and we're kind of starting from much further in. So it'll be a bit tricky for me to actually match our old footage into our new track because the frame ranges were completely different. See in our view here, the frame ranges are 1437 to from 1 to 1437. I think we actually started it, our actual track, much later than that. So again, this is a kind of complex kind of situation to now resolve. We could spend a lot of time changing the offset and the start at to try and match these two footages, but it's going to take a while to kind of match something because these were different different scene setups. So we want to make sure that we export our clip properly. So let's just cancel this for a second and disable, well, let's get rid of our viewport from our main view. Let's just see what we need to do with this camera data that we exported from P-FTrack. First thing we want to do are delete a lot of the points which are kind of really far away. So we don't really need any of those points, and it's going to make our scene really difficult to work with. So if we kind of select all, select say these points within our scene that we know we need for view, and we go to select invert and make sure we haven't got our any of our kind of manual trackers selected or our PF. What we have got selected here is our camera group and our P-FTrack data, and we definitely don't want to delete that. It's just the kind of the auto tracks that are really far away that we want to delete. So we want to make sure we're not deleting any of our PF camera track data, which is kind of linked to our camera. And if we delete that, then we won't be able to have our camera solved and moving. We've also got a keyframe at the beginning of our track, which is making our camera do that. So we can delete that. So it's just kind of animating from there. As a rule of thumb within visual effects, people tend to start their timeframes from 1,000 or from a number that isn't 0, because if you need to kind of go back, and this shot's a great reference, because if we need to go back into our footage and retrack or re-export from sooner, we want this shot to start sooner, then programs like Nuke and other compositing tools won't work in a minus value. So it's important to start your frames from a little bit outside of the 0, so that you can have the option of doing more work before your frame range starts, unless the kind of shot is completely locked off, which in our case, we were the boss, so it was fine, but sometimes you're not in control of those things. So now we have our data. We can essentially select all, group everything, and now we should be safe to kind of move and scale this around without affecting too much of our scene. So the camera will still be essentially moving from here. And then basically this will be saved out as a separate scene. And I will show you kind of what the result of this was. So what you want to do is export your correct frame range, which we didn't do in this case. And you want to be able to essentially start rebuilding your geometry. So before we break, I'll open up the scene that we worked with. We'll save this out, and we'll just explain a little bit about the camera projection within that file. So let's save this in here. So what we've got here is the finished kind of base scene that we use to create the animation for this file. So if we open up the curve editor, and we kind of skim through with our background footage, you can see that we've got our track linked to a whole bunch of geometry that's been made in exactly the right place. And this geometry was just built partly in P-FTrack and partly in Max. And it's essentially using some of the user features that were tracked specifically in specific locations to then build geometry from, and using that as reference points. And then taking that geometry and camera projecting our texture on. And again, this is our way of kind of cheating a very fast texturing method for our model, so that we have contact shadows and global and color bleed of the right kind. So we didn't have to rebuild everything or retexture everything in P-FTrack because we didn't have the photographic resource to be able to capture this properly. Because if we had photographs of everything, we wouldn't have to do this. We just texture it more manually. Whereas what this does, it gives us, at least from the camera's view, a really good cheat of the texture for this scene, basically. The limitations of this method is that if you had a mirror ball here, that would be reflecting this. So there are limitations with this method, but we very rarely came across problems with it, basically. It's a really, really quick fix on texturing your kind of models, and 90% of the time, 100% in our case, it's been absolutely fine, and we haven't came into any problems with the with anything. Because you do get away with quite a lot, even with reflective elements, and there wasn't many reflective elements with the scene anyway, and we kind of got away with it. And we've used this on almost every shot like this, which there's been a few of this year, and it's worked fine. So again, the detail in the model isn't huge, but we've got our camera map binding modifier on with our camera selected, which is our moving camera, and we've subdivided the geometry, which we can have displayed subdivision off or on, preferably off, and this is giving us a great texture to work with. And with that texture, what we've got is essentially a material wrapper with the kind of animated JPEG sequence within the texture, the camera projector selected here, and then that applied to the entire geometry. And then every single piece of geometry has the camera map binding modifier on with the same camera selected here. So it's a very simple, effective way of setting up the scene. And then all the objects will be rendered as alpha contribution -1, so that we are not getting this actually rendered in. We're just getting the contact shadows with using the Vray wrapper matte shadow pass to get our kind of shadows back for compositing and controlling separately. So this is something that we'll talk about more in day 3 about the how this actually works in composite with Nuke. But this is essentially how a starting point for then whoever artist is working on the scene next to be able to start animating and working with this scene. And this afternoon we're going to be talking a lot about a lot of the elements that were animated within this scene. But hopefully this gives you a kind of good introduction to both tracking and how you export your scenes. And it's quite good that we went through some of the kind of troubleshooting issues, because you might come up with some of those again in yourself in the scene. So again, if you were recreating this yourself, you'd want to spend a bit more time on the user tracks, cleaning up the auto tracks, and making sure that your solve was really good, and then making sure that you're exporting your clip to the right frame range. I think that's mainly just deciding at the beginning what frame range you've got, because this footage was essentially a really large piece of footage which we're kind of clipping within here, whereas ideally you'd want to kind of clip your footage not in the display within P-FTrack, but export it as a EXR sequence from After Effects or Premiere, whatever else, and then working on a specific clip separately to your frame range, which will solve some of the issues that we had with this one here. So hopefully that helps and introduce you to the software and the process. And if there's any questions before lunch, we'd take them now.
Maybe I missed you going over this, but what do you do in 3D Studio Max if your alignment to the origin isn't spot on?
Yeah, I mean, again, that's relatively simple, because we've now grouped everything. If we open up that other file, we can literally just rotate and move it around. This file, we made sure that everything worked on a flat plane. We're building our geometry straight, but essentially once you've deleted the auto track features that you don't want, which are too far away, because it always generates like some of the features stupidly far away. That's why we try and delete as many as we can in the model, the ones that are far away in the P-FTrack. But no, once you've kind of grouped everything in a small group, you can just literally rotate and manually move that. You can scale it. You can model a bit of reference geometry, which is roughly the right size as the door, for example. We can model like a 2.2 door. We can kind of scale our P-FTrack until it's kind of some of the points are exactly that scale, and we can just rotate and shift it until it's in the right place, basically. And that's the only way you can do it, unless you have built the model first, which is very rare in any of our cases. It will always be worked with this way around, basically.
Any other questions? All right, in that case, let's break for lunch. It's 12:30, so we'll come back at approximately 1:30.